I would like to discuss what is data structure and then what is algorithm and why do we need to consider DSA, or I shorten the data structure and algorithm to DSA, and some brief introduction to Python, and yeah, let's look at the way to install. I think some of you may know how to install the Anaconda, but some of you may be new to Anaconda, so let's do it together. So what is data structure? So there are many data structures that we can learn in the programming languages. For Python, Java, R, or any other programming languages, they have similar data structure. So we will learn how is array. I think if you learn the computer programming, you know the basic array. And then yeah, we will look at other kind of data structure like linked list, stack, queue, and how can we perform those into some kind of problems or applications. So the data structure means methods of organizing data in your computer. So if you can organize your data correctly, then you can do the the computing in efficient way. So for example, this is a kind of map. Okay, let me just make a very simple map. This is house. If I want to go to store, then there is a path from house to store. If I want to go to the police office, there is a path or there is a road from the store to the police office. If I want to go to the police office from the house, there's also a road to the police office. But if you look at the arrow, I think you know in Korea there is ilbangyang, only one direction. Okay. So this is one direction. You cannot go back here. But if the line has no arrow, it means you can go to the store from house. You can go to house from store. So based on this line, then I know that if I want to go to school, then what should I do? I can go from house to store, and then I go to police office, and then I can go to school. Or I can go from house, I can go to the police office, and then I can go to school. Or I can go from house to the intersection, and then I can go to school. So there are three alternatives if I want to go to school from the house. If I want to go back to house from school, what should I do? There is no many options. If you go back to the police office, then you cannot go to the store. You cannot go to the house. Then the only option is from school to the intersection, and then you go to the house. For this problem, what should I make for the data? So there's one type of data. We can make pair of location. For example, I want to set up the possible route. So from the house to store. And then I can also have the store to house. So let's say this is the problem from 2. So the part, this part is from, and this part is 2. So it is from house to store. This is from store to house, from store to police office, from house to police office, from police office to school, and so on. So this is one kind of data that you can create. So is it the only way to create the data? Actually, no. There is another way. So you can make a kind of array in the array. So I assume that now I'm in the house. So I will look some possibility which places that I can visit from house. So in this case, I can visit store, I can visit police office, I can visit intersection. So one location with many other locations that I can visit. So there's another kind of data structure to save this kind of data. So which one is better? It depends on what you want to find. It depends on what is your goal for this problem. So we are going to learn those kind of things. The next part that you will learn is the algorithm. What does it mean by algorithm? Once we have our data, we need to do something. For example, because of the data is too big, maybe we need to sort. If you want to sort it, then we need to use the sorting algorithm. Or because there are so many data, we want to search some data. So in Google, in Naver, you want to search something because there are too many information. So what is the best searching algorithm? There are some techniques about recursion, dynamic programming, and etc. So we will look at those kind of algorithms. What is the best algorithm? So the algorithm means it is the operations on different data structure. So if you use the pair location, we have one or two algorithms. If we have another data structure, there will be another algorithm. So every algorithms we should analyze. The algorithm analysis means we need to estimate or the estimation of the running time of the algorithm. Because if you run the algorithm very slow, you will not use the algorithm. For example, if you want to use your navigation, if your navigation is very slow, then you don't want to use it because you need to have the possible way that you want to pass as soon as possible. So if we want to make the algorithm, let's say we have the same problem. We have the house, store, police office, school, and intersection. And the problem is find places that you can go from house. Maybe let's say, I have the goal from house to school. Okay, so I need to find places you can go from house. And then from each of the place, let's find all the paths. Okay, find all the paths means if I go from house to store, I can go store police office, I can go police office to school. So I need to calculate the distance because every road has the distance. After I calculate the distance, so repeat this process until you reach the school. Okay, I can go from house to store, store police office to school. So the distance is maybe 10 minutes. If I go from house to police office and go to school, maybe it is 9 minutes. If I go from house via intersection to school, maybe it is 15 minutes. Then after you can find those numbers, we can compare the distance And yeah, we can find what is the best way from house to school. We can find the shortest path. Now, if we want to find the shortest path, which one is the best data structure? This data structure or this data structure? Yeah, the second one. Why?
I think it's much more easier for you.
It is easier. Okay. Yeah, we can look at later on some algorithms how to know that it is easier or it is more efficient, or yeah, there are some other measures to check whether the algorithm is suitable or not. Okay. But yeah, for now, it is easier for now. If we use this one, you need to check all of those possibilities. So if I want to know from house to school, then I will check one by one. So from house to store, okay, we have access one, and then we will check maybe the distance. Store to house, then it is not possible because we will detour. It means from house back to house. From store to police office, okay, we can continue from house to store to police office. And then house to police office. Okay, then if we know the starting point, there is an option to go to police office. And so on. So it means we will check one by one. But if we use this data structure, we can check. Now I'm in the house. There are three possibilities. I can go to store. Okay, after I go to store, then I will check the store information. So from the store, I can go to house. So I will not check this one. From the store, I can go to the police office. Okay, I will check the police office. And then I will go to the police office and then check what is the destination. Okay, I can go to school. Okay, if you use this algorithm, that's much easier or efficient. But there can be another way to solve this kind of problem with the same data structure. So we will learn, how we can do the algorithm with the existing data structure. So why do we need to consider the data structure and algorithm? So when the data is big, okay, so you can see only the examples of the data. We have only 5 locations. But let's say if you want to go from Seoul to Busan, so how many points that the navigation should analyze? It's about the volume. There are so many data. There are so many points in South Korea. Variety of data. Okay, if it is about just navigation, it is not that complex because it is only point. But if it is about the current issue like ChatGPT, there are so many data in the world and ChatGPT can solve the problems. So the variety of data is also one of the issue in the big data. Velocity. Velocity means the speed. You want to get the result as soon as possible. So in my research, when we do the training, data training, sometimes it takes like 1 week. So it is very slow to do some kind of training data. So we do not want to do 1 week. We want to get as soon as possible. So the velocity is another issue when you have big data. Velocity. Maybe you have many data, but not all data can be trusted. Some data might be errors. Some data might be the outliers. Some data you cannot use for the analysis. So how can you check that? Value. So some data might be valuable for the business, but many data are not valuable. And the variability. The variability means the data that can be used and formatted. There are so many different ways. You can use array, and if you learn about the deep learning, you can use tensor data. If you use other way to solve the problem, there will be another kind of data type. Yeah, there are so many data types that you can use to analyze the data. This is one example. This is the data about taxi in Beijing. So one company, they try to capture the movement of taxi in Beijing, and it is the 67,000 GPS equipped taxi cabs in Beijing. So it's very complicated. Maybe we want to know when is the traffic happen. Then you need to analyze those data. The problem is when the algorithm is complex, so you need to understand the analysis of your algorithm. So we will learn about this one. Whether the algorithm will be constant, the number of objects means the number of data. If the number of data is 1 million data, okay, maybe this is the time or number of operation. So if the data we have is 1 million, the time is 1 minute. If we have another data 2 million, the time is still 1 minute. If we have 3 million data, the time is still 1 minute. Oh, that is good. This is a good algorithm. But is it possible? It's very difficult to find the algorithm that can give you this kind of reading. So usually, we use the linear or the quadratic or any other analysis. The linear means when the data we have is 1 million, maybe the operation time is 1 hour. When we have the data is 2 million, maybe the operation time is like 2 hours. So the operation time increase when the number of data increase. Or some algorithm is quadratic. When the data is like 1 million here, for example, it is 1 hour. When the data is 2 million, it becomes 1 day. And it will be more complex. So we will learn how to analyze the algorithm. And there's also another issue with the utility computing. If you use your desktop, maybe it is good. But if you use your laptop, the performance will be degrading. Laptop is slower than the desktop. Or if you use your tablet, or if you use your smartphone, then the computing performance will be different. If you use cloud, if you use some cloud, for example, you know about the Amazon Web Service, or the GCP, Google Cloud Platform. Whenever you use those kind of platform, you need to pay some money. And the payment is based on the minute that you use. So for example, you want to use the virtual CPU, you want to use 2 virtual CPU, and then the memory that you want to use is 8 gigabyte. So if you run your analysis in this AWS, it is the Amazon, then for 1 minute, you need to pay $0.0928. If you use Microsoft Azure, then you need to pay this amount of money. If you use Google Cloud Platform, you need to use this amount of money. Oh, sorry, this Azure is per minute, but the AWS and the GCP is per second. Then you can imagine if you run your training data in 1 day. So 1 day is 24 hours. 24 hours, we have multiplied by 60 minutes. Then you can know how much you need to pay for the server. If you do not calculate this computing performance, then you will pay many more. So that's the reason we need to understand the data structure and algorithm, because the company nowadays, if they perform this kind of data structure and algorithms, they want to make more efficient. They want to minimize the cost. So how we can minimize the cost with the algorithms? So we are going to use Python. So some introduction about Python is, this is the author. It was created in 1990 by Guido van Rossum. So he was at Amsterdam at the time. And Python is free, it's open source. There are so many community, and it is object-oriented language. So everything, it can be an object. So we cannot do Python just in short time frame, but yeah, hopefully it will give you a taste of the language. So during one semester, I hope that you can try to figure out how you can use Python. And there are so many books, there are so many tutorials, there are so many library references in the internet. You can use any of those. Even though I have the reference for this class, but I guess you can also find some Korean books that you can use, or you can learn for the Python in the data structure and algorithm. Python.org is the official website. So if you want to check any tutorials or reference manual, then you can use that website. Or if you have any problems, let's say when you develop your algorithm, you have errors or you cannot solve the problems, you can go to Stack Overflow. Some of people on the GitHub, they also share how to solve the problems and etc. It will enrich your knowledge on Python. So let's install it. I think in the computer that you use in this room, the teaching assistant already installed Anaconda. But if you want to use in your personal computer or in your laptop, then you can just download the Anaconda. I think last year they mentioned this Anaconda as the individual edition. But this year they mentioned this one as the distribution edition. So the Anaconda distribution, it is the individual edition. So you can download this one. It depends on your operating system. If you use Windows, you can download for Windows. If you use Mac, you can download for Mac. If you use Linux, you can use the Linux version. Okay. It has a different installer for Windows, Mac OS, and Linux. Okay, so please download it if you don't have it. Oh, I guess I have the files in my computer. Okay. So actually now Anaconda have the way to code in the cloud. So if you sign up in the Anaconda, you can use the Anaconda in the cloud. But I do not want to use it. If I think it's better to use the offline, the Jupyter Notebook, so you can practice by yourself, okay? Even though there is no internet. For the files, okay, I already downloaded this one. So I have one thing that I would like to inform you. When you set up the Anaconda, make sure that you install it in the folder without Korean letter. So in this case, I use C users and the username is IME. It is alphabet ABC, not Korean letter, not Hangul. So if you use Hangul for this one, there might be errors when you execute the Anaconda. So make sure that the destination folder is not using Korean letter. And if you already set up the destination folder, you can go next and then it will install automatically. I already have the Anaconda in my computer, so I will skip this one. For this course, I will use the Jupyter. Can I know, did you install the Anaconda already? Who have not installed the Anaconda in laptop? I know, yeah, 1, 2, 3, okay, 4. So you can download now. You can try to download if you bring your laptop, okay? And let's figure out if there is any problem or not. So after you finish the installation, this is just my recommendation. Some computers may automatically generate the path. The path means when you run the Anaconda, you can run in any command prompt or in any program. If you can run in any program, it means the system environment variables already know where is your Python file. But some of the computers, you need to do this manually. You need to define where is your Python file. So for the Windows computer, yeah, I can recommend to use this one. For you who use Mac, I'm not sure how to handle with Mac, but if you have any issue, let me know. I will try to find some solution. Okay. So for this kind of setting, yeah, because I'm using the English name is the edit the system environment variable, but in the Korean, it is system 환경 변수 편집. Maybe you can write later. So system 환경 변수 편집. And then you need to edit. You need to modify okay, you need to modify this environment variables 환경 변수. In the path, okay, there is a path here. The path means whenever you want to access any programs, you can access from anywhere. So you need to define where is your Anaconda. So in my computer, the Anaconda is in this folder. So I can just copy this one. And then let's see. I can go to this path and you will look at the folder. It contains the Anaconda files. So you need to find where is your Anaconda files located, and you need to put it into the 환경 변수 편집. So there are three links that you need to use. The first is the Anaconda tree, and then you need to access the Anaconda tree scripts, and you need to access the Anaconda tree library. So make sure that those three are available in the in the environment variables. Anaconda tree, library, and scripts. So once you already set this one, you can press again. Then yeah, I think you are ready to use the Jupyter Notebook. So you can, if you don't have that one, you can click new and then add those link to your environment variables. So after you set up those environment variables, you need to ensure that the Python Anaconda works well. Because when we use the Jupyter Notebook, I will use both the Python and Conda. If the Python cannot work well, we can use Conda. So how to check if your Python or Conda works? You can go to the command prompt. There are so many command prompts. If you confused, you can use Anaconda command prompt. If your computer works with the Anaconda properly, then you can find the Anaconda prompt. And when you have this display, you can check Python. So if there is no error, then it means your Python installed perfectly in your computer. If you want to quit, just Control Z, then quit. Okay. So I will stop here first to check some of the students who have now installing the computer. So let me explain a little bit about the Jupyter Notebook basic. So you can try to download if you don't have your Anaconda in your computer while you're downloading and while you're installing. Maybe during the break time, I will help you if you have any problems. So we are going to use the Jupyter Notebook. The Jupyter Notebook is an open source web application. You can use it to create and share documents that contain live code, equations, visualization, and text. So actually, if you can set the Jupyter environment, you can do code in live with your friends. Or maybe the easy way to use the live code is to use the Google Colab. So this one is the example of the Jupyter Lab. Jupyter Lab is the next generation user interface for Project Jupyter. You can use the notebook in the Jupyter Lab. So it is not the classic Jupyter Notebook, but it is the next generation of the Jupyter Notebook. So you can have many functions like the notebook itself. We can use the terminal, so we can connect to the computer. And then we have the text editor, so yeah, you can make some text file, or you can have the CSV file and etc. You can browse. There's a function to browse in the internet, and there are many other rich output that you can use. We can use the HTML. We can use some JavaScript in the Jupyter Lab. So the basic idea of the Jupyter Lab is to bring all the building blocks that are in the classic notebook plus some new stuff under one roof. So you can look at one notebook and another notebook in one application. When you install Anaconda, you can use some of the embedded library in Anaconda. Yeah, you can use the Jupyter Lab, you can use the Jupyter Notebook, you can use Spider, you can use Qt, and etc. So they already installed some basic tools for the analysis, and Jupyter Notebook is one of them, and Jupyter Lab is also one of them. So they distinguish between the two, Jupyter Lab and Jupyter Notebook. When you familiar with the Jupyter Notebook, it will be easier for you to do online. The online tools means you can use Kaggle. In Kaggle, their environment is very similar with the Jupyter Notebook. So if you are familiar with the Jupyter Notebook, you can use Kaggle easily. Or yeah, you can use the Google Colab. So with the Google Colab, you can use the Jupyter Notebook environment online. So if you can access Google, then you can use the Google Colab. Okay, that's all for the first part. Any questions?